Hey there, welcome to P5.2. If you have not watched P5.1, you need to stop this video and go watch that right now because P5.1 is a prerequisite. You need to know that stuff first. And actually, it's not much different than what the outcome is wanting you to do in 5.2. And so this particular video is going to be very short. And if you know 5.1 really, really well, you will have no problem with 5.2. Okay, write, solve, and verify solutions of single variable one-step equations with whole number coefficients and whole number solutions. Now this is a big bunch of lovely words, but you've actually done this already. So single variable just means one variable like we had. There you go. There's your variable. Anytime you use a letter as a replacement for a number that you don't know, it's called a variable. One-step equations, so the step here is to figure out what did we subtract from 7 to get 5. We're using whole numbers. Coefficients means the numbers that are in the equation that aren't variables. So there's a word that you can put in your math book. And whole number solutions. So even though we could probably eyeball this question and think, well, 7 take away something is 5. Gee whiz, that something must be 2. I'm going to show you a logical way to solve single variable equations. And this will help you later on, especially in grade 8, 9, and 10, when you have a little bit more complicated equations that you need to solve. It's basically the same process. You just need to do one step at a time. And so the indicators here say identify experiences from your life. Of course, they love that one. It's got to be in every math outcome. They've given some examples. You could do temperatures, cost of a DVD, size of a plant, anything you're measuring really that you could represent with a chart. Performance of a team goalie. You could use a variable to represent any of those things. So describe a situation for which a given equation could apply and identify what the variable represents in the situation. Solve single variable equations with the variable on either side of the equation. So if I did it like this, it wouldn't freak you out, right? It's saying 5 is exactly the same as 7 take away some number. Well, that number must be 2. Okay, so we're going to move on to this lovely blank screen. I'm going to give you some questions. And actually the questions I'm giving you are coming right out of the grade 7 textbook. So solving single variable equations doesn't change much from year to year. Okay, so we'll try this one. Okay, so something, when it gets added to 12, will give you 19. So we can probably use our heads and think, well, that something must be 7. But I want to show you how to do this in a logical way. If we have a variable, such as z, the whole mission of math when you're using variables is to get that variable all by itself with nobody else beside it on that side of the equal sign. Okay, so remember that your equal sign is like the balance of a scale. If I do something to one side of my scale, if I add to one side, I have to add the same thing to the other side to keep it equal. I should have maybe drawn it straight. That would have made a little more sense. Sorry for my crooked drawings. Okay, so in this case, what is happening to Z that is preventing it from being all by itself on his own side of the scale? Well, 12. That's what's happening to it. 12 is being added. So now we have to think about, well, what's the opposite of adding 12? The opposite of adding is subtracting. What would 12 take away 12 be? Well, it would be 0. So if we took 12 away on this side of the scale, we would get rid of that chunk, right? And then Z would be all by itself on this side of the scale. That's all fine and lovely, except what we do to one side, we must also do to the other side. Okay, and that leaves us with the question of, what is 19 take away 12? Well, it's 7. And don't forget that your equal sign goes in the middle, so Z equals 7. Okay, let's try another one here. Okay, so remember that the equal sign is a scale. Right now these two things are equal. This side is equal to 8, and this side is equal to p minus 1. They're exactly the same. So if I do some stuff to one side, I have to do that same stuff to the other side, or else my scale will not balance anymore. So the mission, should you choose to accept it, is to get p all by itself on its own side of the equation with no neighbors, no friends, and nothing happening to it. But this is happening to it. How do we get rid of that? What's the opposite of subtraction? You're going to add. Okay. So if I add on that side of the equal sign, I need to add on this side of the equal sign. Okay. So this is canceled out. My minus 1 and my plus 1, they're gone. P is left all by itself. My equal sign is going to happen. And 8 plus 1 is 9. So there's a couple of important points I want to show you about solving equations, and this is going to help you for the rest of your life solving equations. Do you notice how I've made the equal signs all line up? I did that on purpose. And that will help you keep you organized. You don't want to ever have an equal sign not line up, and you don't want to put more than one equal sign on a line. Okay, you want to always drop down to the next line and rewrite your stuff in a more organized way. Okay, so when I started, I had p minus 1 equals 8. I added my 1, and then I crossed out those 2 because they cancel out. I kept my equal sign. What I did to this side, I did to this side. And then I dropped my p. He went down here. And then I added what was left on this side. Look at all the marks. And that gave us 9. So keep your equal signs lined up. Save some room to write in what you're doing to each side. And remember the rule of what you do to one side, you must do to the other. Okay, let's try a couple more. We're going to use R. Okay, this time we're using division. My R is not all by itself on this side of the equal sign, right? There's my scale. What is happening to poor little R? Well, he has a line underneath of it, which means divide. He's getting divided by 2. So when you have a fraction, sometimes a good way to think about getting rid of a fraction and undoing your fraction is think about, I wish I had a 2 on the top so that I could cancel both of them out, because anything over itself is 1. So if I had a 7 on the bottom, I would put a 7 on the top to cancel it out, because 7 over 7 is 1. 10 over 10 is 1. 1 bajillion over 1 bajillion is just 1. Anything over itself is 1. So when you have a variable that is being divided like that, you want to put the number on the top so that you can cancel it out and be rid of it. And what you're actually doing by putting that number up top is you're saying 2r, which means the 2 is being multiplied by the r. Okay? But because there's a 2 on the bottom, we're canceling it. Now, what did I do to this side that I must now do to this side? Well, I put a 2 there, and I was multiplying. You can't just put a 2 there and call it 24, right? You're actually multiplying that by 2. Okay, so when you look at your equation, what's left on this side of the equal sign? The 2's are gone, all the fractions are gone, all this stuff is gone. You're left with r. And I've dropped it down right below, and now I'm going to drop down my equal sign, and I'm going to figure out what 2 times 4 is and drop it down right there. Okay, let's do another one down here. P over 4 equals 3. Some number that we don't know, we're calling him P right now, some number is getting divided by 4, and that gives us 3. Well, what do we wish we had on the top of the fraction so we could get rid of that 4? Gee, I wish I had a 4. Boom. But if I put a 4 on the top on that side, I better put a 4 on the top on that side. Don't forget your brackets because you're multiplying here, people. I'm going to drop down what's left of my equation and figure out what 3 times 4 is. And you're done. You probably won't have examples that are that difficult in grade 5, but you'll be so prepped for grade 7 when you get there. It's going to be awesome. Okay, let's try a couple more single variable equations here. Okay. Some number, w, plus 3 gives us 7. So if we were going to do this the logical mathematical way, we would say, well, I want to get w all by itself. It's got this 3 sticking to it. I want to get rid of that 3 by using the opposite. So they're gone. What I do to one side, I must do to the other. All that's left is my w, keep my equal sign, 7 take away 3, boom. Okay. 6, take away something that we don't know, is equal to 2. Pardon me. So in this case, we could do it mathematically, but that ends up having a bunch of negatives and switching sides and whatever. It's kind of complicated. You will learn that next year or the year after. For now, let's just think in our heads. We have 6 of something. We're going to take away some of them, and that leaves us with only 2. So I obviously took away 4. But you can still write it in your organized way where you're dropping down the P, dropping down the equal sign, and dropping down your answer. Okay, the next one, 4 times something, right? Because when they're stuck together, when the variable and the number, the coefficient, are stuck together, that means it's being multiplied. So you could think about it mathematically. What do I wish I had on the bottom to make that 4 disappear? Well, I wish I had a 4, and that way I could cancel them out. But if I'm going to draw a line, which means divide, and put a 4 on this side, I better be doing that to this side. So if I drop it down, I don't have much room here, x equals, what is 16 divided by 4? There you go. Okay, last one, 50 divided by something, we don't know, gives us 5. Well, I wish I had a, let's see, you can do it this way. I wish I had an x up here, and then that would get rid of my x's. But I put an x on the top on one side, so I guess I better put an x on the top on the other side. And now you look at it and go, oh darn, my x is still not by itself. Now it's got a 5 stuck to it. Well, let's divide the 5 away. What I do to one side, I need to do to the other. Now my 5's are gone. My x is all by itself. My equal sign is good, and 50 divided by 5 is 10. So that's a bit more complicated than what you actually need to know, but for those of you that are feeling pretty spunky about variables, you could do that for sure. If it was regular grade 5s that had this kind of a question, they would probably just be thinking in their head, 50 is getting divided by something, and the answer is 5. So if it was, remember that division and multiplication, if there are two factors at the bottom, so the 5 and the we don't know, we can think about 50 divided by 5 is x, or 50 divided by x equals 5, or 5 times x equals 50, because multiplication and division facts are related like that, right? You can show them 3 different ways. You can put the two factors together, and it doesn't matter what order, to give you your multiplication fact. So in this case, we could think about this top one. Well, 50 divided by 5 is 10. So that gives you your answer. So a couple different ways to think about it. Happy variable-ing, how's that for a word?